In lesson 6.5, you will graph square root and cube root functions. First, we're going to graph y equals the square root of x, which is the parent function for the family of square root functions. To graph it, we're going to make a table of values. And in for x, since I can't take the square root of a negative, I'm going to put 0, 1, 4, and 9. 0 is the smallest number that I can take the square root of, and then I put in some perfect squares so that I'll get some nice y values. So putting 0 in for x, the square root of 0 is 0. Putting 1 in for x, the square root of 1 is 1. Put 4 in for x, the square root of 4 is 2. And finally put 9 in for x, the square root of 9 is 3. So we'll graph 0, 0, 1, 1, 4, 2, and 9, 3. And the curve through those points then looks like that. Okay, so you can see that the domain is all x greater than or equal to 0, because we can't take the square root of a negative, and the range for this parent function is y greater than or equal to 0, because when we take the square root of those numbers, we'll never get a negative value. Now let's graph y equals the square root of x plus 4 minus 1. We'll make a table of values, and I'm going to choose my x values carefully because I want to take the square root of 0, so I'll let x equal negative 4. I want to take the square root of 1, so I'll let x equal negative 3. And I want to take the square root of 4, so I'll let x equal 0. And now get my y values. When I put negative 4 in for x, I'm taking the square root of 0, which is 0, and 0 minus 1 is negative 1. When I put negative 3 in for x, I'm taking the square root of 1. Square root of 1 is 1, and 1 minus 1 is 0. When I put 0 in for x, I'm taking the square root of 4, which is 2, and 2 minus 1 is 1. So we'll graph negative 4, negative 1, negative 3, 0, and 0, 1, so that we can draw that curve through those points that looks a lot like the parent function, only when we compare it to the parent function, there's a translation left 4 units and down 1 unit. Now we can tell from the equation that we're going to have those translations because our h value is negative 4, causing this curve to go left 4 units, and our k value is negative 1, causing it to go down 1 unit. The domain and range, domain is all x greater than or equal to negative 4, and the range is all y greater than or equal to negative 1. Okay, next we're going to graph the parent function for the family of cube root functions. F of x equals the cube root of x. So again, we'll make a table of values, and I can take the cube root of negative 8, I can take the cube root of negative 1, I can take the cube root of 0, I can take the cube root of 1 and positive 8. I'm going to choose those values so that I get nice y values. The cube root of negative 8 is negative 2, the cube root of negative 1 is negative 1, the cube root of 0 is 0, the cube root of 1 is 1, and the cube root of 8 is 2. So I'll graph negative 8, negative 2. I'll graph negative 1, negative 1, 0, 0, 1, 1, and 8, 2. And then I'll draw this curve for this function that's rather S-shaped. Okay, and you can see that the domain and range for this parent function are all reals. We can take the cube root of negatives, we can take the cube root of 0, and we can take the cube root of positives. And the result, the y values, will be negative, 0, or positive. Okay, now let's graph f of x equals the cube root of x minus 2 plus 1. So we'll make a table of values. And I'm going to choose those x values carefully again. I want to take the cube root of negative 8, so I'll let x equal negative 6. I want to take the cube root of negative 1, so I'll let x equal 1. I want to take the cube root of 0, so I'll let x equal 2. I want to take the cube root of 1, so I'll let x equal 3. I want to take the cube root of 8, so I'll let x equal 10. And now I'll find my y values. When x is negative 6, I'm taking the cube root of negative 8, which is negative 2, and negative 2 plus 1 is negative 1. When I let x equal 1, I'm taking the cube root of negative 1, which is negative 1, and negative 1 plus 1 is 0. When I let x equal 2, I'm taking the cube root of 0, which is 0, and 0 plus 1 is 1. When I take the cube root of, or when I let x equal 3, I'm taking the cube root of 1, which is 1, and 1 plus 1 is 2. And finally, I'll let x equal 10 and take the cube root of 8, which is 2, and 2 plus 1 is 3. So I'm going to graph negative 6, negative 1. I'm going to graph 1, 0. I'm going to graph 2, 1, and 3, 2. And finally 10, 3. So I'm drawing again this S-shaped curve that looks like the parent function, but it has a translation. There's a translation right 2 units and up 1 unit. And again, we can tell that from our h value, which is 2, and our k value, which is 1. And the domain and range for this cube root function is all reals. Okay, in our final graph, we're going to graph a cube root function, y equals negative 2 times the cube root of x minus 3 plus 2, and state the domain and range. Then we're going to compare the graph with the graph of the parent cube root function. So let's make our table of values. And let's choose those x values carefully. I want to take the cube root of negative 8, so I'm going to let x equal negative 5. I want to take the cube root of negative 1, so I'm going to let x equal 2. I want to take the cube root of 0, so I'm going to let x equal 3. I want to take the cube root of 1, so I'll let x equal 4. And I want to take the cube root of 8, so I'll let x equal 11. And now solve for y. When x is negative 5, we're taking the cube root of negative 8, which is negative 2. Negative 2 times negative 2 is positive 4, and 4 plus 2 is 6. Now let x equal 2, so that we're taking the cube root of negative 1, which is negative 1. Negative 1 times negative 2 is 2, and 2 plus 2 is 4. Now let x equal 3, so that we're taking the cube root of 0, which is 0. 0 times negative 2 is 0, and 0 plus 2 is 2. Now let x equal 4, so that we're taking the cube root of 1, which is 1, and 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. And 11. We'll let x equal 11, so that we're taking the cube root of 8, which is 2. 2 times negative 2 is negative 4, and negative 4 plus 2 is negative 2. So we'll graph negative 5, 6. And we'll graph 2, 4. We'll graph 3, 2. and we'll graph 4, 0, and finally 11, negative 2. And then draw that S-shaped curve through those points. Okay, and when we compare this graph to the parent function, we see that there's a translation right 3 units and up 2 units. And also there's a reflection. That a value is negative 2. Because that a value in this equation is negative, it's causing a reflection, which means this curve rises to the left and falls to the right, where the parent function falls to the left and rises to the right. And you can see that the domain and range again are all real numbers. Include with your notes of this video guided practice problems 2 through 10 even, found on pages 447 and 449 of your textbook.